sorry. This will be fun to watch on YouTube later. Okay, that's better. All right. I'm sorry? Oh, it's not on the screen. Nice. How'd that happen? Let's see if I can fix that. Okay, there we go. Yep. Fixed it. Maybe, and then I broke it again. All right, cool, we're good. All right, so today we had two primary topics that I want to talk to you about, and I've actually got another kind of bonus little exercise that I want to talk to you about today as well. The first thing that I want to talk to you about is this concept of MVC, Model View Controller. So it's a very widespread technique, very widespread paradigm within the world of programming, especially within the realm of web development, although it's not solely restricted to web development. But who can explain to me what these different pieces are? Who can tell me what a model is? What's a model? If I look at a program, specifically the kinds of programs we've been developing lately with HTML and CSS and PHP and all that stuff, what are you going to tell me is the model? Yeah. That's your database. Yeah, exactly. The model is roughly equivalent to your database. So we're going to talk about databases kind of towards the end of class today, but that's the model. That's the model piece of MVC. What's the view? Which part of these programs is what? Yeah. Yeah, so the view, it kind of implies, you know, it's how is it everything displayed? How does the user actually see this stuff, right? So the view is what's actually visible to the user, how they interact with the website. And then what's the controller? Well, hang on, wait, before we talk about controller, what kinds of stuff coding-wise makes up the view? HTML, CSS, that kind of stuff, right? Yeah, all right. So what's the controller then? What's the controller for? Yeah. Yeah, so you're on the right track, absolutely. PHP, yes, absolutely, 100%. It doesn't have to be PHP, there's lots of other languages out there, but we're using PHP for the controller. And it's what controls all the logic, right? So if I click on something, what do I want to actually happen? That's a question for the controller to answer. The controller is what's actually going to manipulate the view based on the model and input from the user. Right? So the three pieces are separate from one another, but they also interact with one another. They work in conjunction with one another to display, in this case, a web page that a user can interact with. You don't need all three pieces. They're not all required. In fact, we're going to take a look at a website today that doesn't really have so much of a model involved, but it does have a view and a controller. Later on, we will put a model into things. In fact, on today's studio is a great example of MVC application. So what's the benefit of all this? Why do we spend so much time talking about it in the prep work? Why are we talking about it right now? Why don't we just make a website like we've been doing in Module 6, for example? Yeah. Say that one more time, I didn't quite hear you. It's going to limit what the user can manipulate. So it certainly gives us the ability to do that kind of stuff. Yeah, absolutely. How? How does it limit what the user can manipulate? Yeah. Right, so by keeping these things separate, it allows us to administrate each of those pieces separately. So if we're worried about things like security, we're worried about things like who can access what, it helps us to keep those things independent from one another so that the user can't just go poking around in our database, right? We usually don't want that. In fact, securing databases is a very important thing. Anytime you see these big data leaks, right, where's it coming from? It's databases that people didn't secure or other kinds of documents that people didn't secure. Using a good MVC design will help prevent those kinds of things from happening. Exactly. What about from a coding perspective? What about from a design perspective? How does this help us? Yeah. Absolutely, that's a great point. So the answer was it's kind of like when we factored stuff out into functions in C. I love that analogy. It's a great analogy to what MVC is doing for us. It allows us to keep the logical stuff separate from the actual content, which means if I need to change something, I don't have to go find a whole bunch of different spots. I can just go to the one spot that contains the logic, and then everything else will be updated automatically by default. We're going to see some examples of just that in a little bit. So let's say you have a website, and it's maybe not so great MVC design, right? It's got some drawbacks. What are you going to look for if you want to try to convert this into something that's more of a MVC type approach? What kinds of things are going to stand out as flags that this could be designed a little better? Yeah, in the back. Things you repeat, yeah. Hopefully you kind of got that feeling from C as well. As programmers, anytime I see repetition, anytime I see something that looks like it was just copy-pasted 10 times, that just makes me feel bad on the inside. It's not a good thing. Programmers should be able to write code once and then reuse that code whenever they need to. That's what MVC is really trying to push us towards. We saw similar concepts in C as well with functions, right? Great. Any questions about MVC stuff? We're going to see an example in just a little bit. Any questions I can answer right now? Alrighty, let's move on to the second major topic that you had to prep for today, which is SQL. First up, how's data stored into a database? If I give you a database and you peel the lid off of it and you take a peek inside, what are you going to see? What are you going to see in that database? Yeah. Tables, rows, and columns. So anything that you ever want to put into a database, think of how it fits into tables, rows, and columns. So let's talk about that a little bit more, actually. What does a table actually represent in a database? Can you think of what a table should be used to represent in your database? It's kind of a general question, but yeah. Yeah, so that's a good description, actually. A group of items that share similarities. We actually have a name for that. I don't know if it was mentioned heavily in the prep work or not, but you might have heard it referred to as an entity before. So a classic example of an entity might be a person, right? People. There's lots of different people. We all have some things in common. We all have eyes, we all have hair, right? We all have names, we all have social security numbers, hopefully. Stuff like that we have in common. So that makes it easy. That's something that indicates that maybe we want to group these things together. But we also have lots of different things about us. We all have eyes, but they're all different colors. We all have social security numbers, but they're all different, right? I hope you don't have my social security number. That would be a bad thing. So we can use a database to not just keep track of the similarities, but also keep track of the differences across those objects. So what does a column then in a table represent? What does a column represent? Yeah. A category of information or like an attribute. Yeah, something like that, right? So if I'm using my person, my people as an example of my person table, I might have a column for a name. I might have a column for an address. I might have a column for social security number, for anything that I'm tracking about those particular people. Right? And then what's a row represent in a table? Yeah. I'm sorry? The value, or the official computer science term would be an instance, right? If I look at a single row in my person table, that represents one person. Could be me, it could be you, it could be somebody else. If I have 10 people that I want to put in my database, that's 10 rows in my person table. 10 different instances of a person is how I would say that in computer science lingo. Good. So anything that you ever want to store in a database has to conform to that. Model. That's actually not exactly true. There are alternative database models that don't necessarily conform to tables, rows, and columns. But for this class, tables, rows, and columns are what you need to know. What are the 4 main SQL operations that were mentioned in the prep work? Yeah. Yep, select, insert, update, and delete. So some of those I think are maybe fairly obvious what they're for, like insert is for what? What is insert for? Yeah. Putting new data in, right? What am I inserting? Am I inserting tables? Am I inserting columns? I'm inserting rows, right? I'm inserting rows. I'm always inserting rows, right? What about updates? Maybe even a more obvious one. If I want to change something, right? I want to change a value. It's already in there, but it's wrong, or it just changed for whatever reason. I need to update it. Delete, of course, takes stuff out. What about select? What does select do for us? What is a select operation for? Yeah. Getting stuff out, right? Reading data. So inserts, updates, and deletes, you have to be a little bit careful about using those. They're permanent. There's no control Z with databases. When you put it in there or when you delete it, it's just gone. It's just gone for good. Select, however, it's just reading. It's just retrieving information. Select's pretty safe. It's hard to do damage with a select statement. Is there a question? Insert is, yeah, so the question is there a difference between insert and update? Yes, there very much is. Insert is for brand new data, data that does not exist anywhere. Update is, there's a row that's already in here, or maybe multiple rows that are already in here, but I want to change some values in those rows, so I use an update statement. Basically, after I run an update statement, I'm going to have the same number of rows that I started with. After I run an insert statement, I'm going to have more rows than I started with. Okay. What are some common data types that you're going to see in SQL that were mentioned? So in C, we had things like, what, ints and strings and that kind of stuff. What do we have in SQL? Did you guys see it? Char, char, whatever. I'm not going there today. I promise. Yeah, that's our text data, yeah. Varchar, yeah, yep. It rhymes, Varchar, rhymes. What's the difference? What's the difference between just a regular old one of those things and a var one of those things? Yeah. Right. So chars are fixed length. That means if I say that I've got a column in my table with a char of 100 letters, and I only give you 2 letters, what's it going to do? It's actually going to pad it out. It's going to add a bunch of spaces after it until you get to 100 letters in length. Everything's going to be 100 letters. Everything. If you don't have 100 letters, then I'm just going to put spaces on the end until it gets that far. A varchar won't do that. A varchar just takes whatever you give it. And there's a trade-off that was mentioned in terms of processing performance, stuff like that, which is good to know. I mean, we are concerned about performance with databases. Databases are not the fastest thing in the world. They're actually kind of slow. Generally, and so optimizing database performance is a very hot topic, but not one that we're really going to touch upon too much, at least not today. Any other important data types that you noticed you were going through? Yeah. Enum, yeah. It's short for enumeration. Yeah, it's short for enumeration. Those actually exist in other languages as well. I believe C can do those. I know C++ can. I believe C can do those as well. What's an enumeration or an enum? You remember? So yeah, that's a good description. If we want to, I think a good single sentence description is just I have a list of stuff and I number all of them. That's an enumeration, right? I give you a list of things and I just apply a number to each one. 1, 2, 3, 4, 5. Sounds kind of like an array almost, of sorts. It's not exactly the same thing as an array. I don't want you to walk away thinking that an enum is an array. That's not true, but you could definitely make a comparison between the two. Yeah. Okay, there are lots of other SQL data types available. In fact, the version of SQL that we're using, MySQL, has quite a few data types available to you, which will become important when we start doing manipulations in SQL. What's a join? Can somebody explain a join to me? This is probably people's least favorite things about SQL when they first learn about it. Yeah. Yes. All right. So this actually opens up a whole kind of Pandora's box of stuff for us to talk about. So a regular select statement, if I just run a select without a join, how many tables am I referring to? Am I allowed to refer to? Just one. A select statement without a join, I can only get data out of one table, which is fine for lots of stuff. In fact, a lot of the queries that we're going to look at today, I just need one table. I just need one table involved. Eventually, as your programs get bigger and more complex, just getting data out of one table is not going to be good enough. I'm going to need to get data out of multiple tables at the same time. And in order for me to do so, I have to use a join. A join is the mechanism that allows me to pull data from multiple tables in a database with a single query. So how does it work? There's actually a few important pieces of tables that we haven't talked about yet that make a join possible. The first one of those items is a primary key. Can somebody explain what a primary key is? What's a primary key in a database? Yeah. Yep. Yeah, it's a unique identifier. Yep, that's exactly right. It uniquely identifies everything in a single table. So if I have a table with people, I have a primary key that uniquely identifies each person. Now, you might think, maybe Social Security would be a good primary key for that particular table. You have to be a little bit careful about that, though. Social Security numbers, especially these days, it's possible for those to change, and we really don't want our primary keys to ever change. They should be set in stone, if we can, ideally anyway. So more often than not, what you're going to see as a primary key is really just a numbering: 1, 2, 3, 4, 5, 6, 7. I'll just make a new number for each row that I put in and just count that. All right, why is that primary key important for the join then? We need some way of connecting those two tables together, right? If I'm pulling data from multiple tables at once, I need to have something that tells me what the connection is between those two tables. Otherwise, I don't know how to merge those two data sets together. And that's actually what the primary key is going to help us do in a lot of cases. So the way that it works is I'm going to take that primary key, and I'm going to actually put those primary key values in a different table, in a second table. And that has a special name. Does anybody remember what that's called? It's called a foreign key. So if I see a primary key in another table, that's called a foreign key. And so then when we join, it looks at the primary key on this table, and it looks at the foreign key on this table, and if they match, it merges those two rows together. That's how a join works. That's sort of a high-level, quick and dirty version of how joins work. There's a lot more going on under the hood than what I just explained. They can be tricky. They can very much be tricky, but extremely, extremely useful and a good skill to master, especially if you're going to be doing a lot of work with databases. Yeah. So a way of thinking about this is the primary key and the foreign key, they actually mean the same thing, right? The difference is the primary key is a unique identifier in one table. It's not a unique identifier when it's acting as a foreign key. So the same number could show up multiple times in the foreign key side of the table if there are multiple matches. Let me try to think of an example. So like if we use our person example from before, I have one table with people in it. One person could have many different cars, for example, or many different anything really. I'll just use cars. I already said it. So what I could do is for every car that I have in my database, I could attach that person's primary key to that car so that I know that car belongs to this particular person. And then if I want to find out, how many cars does this particular person have, it looks at their primary key, it goes to the foreign key in my cars table and tries to find all the occurrences of that primary key, and then it matches them up that way. So great question. Thank you for asking that. More detailed explanation was definitely warranted. Any other questions? Joins are tricky. I probably did not do them entire justice, but you'll get some practice with them a bit later. What's an index? Somebody explain an index for me to me. So, what's an index in a book? We've all seen those before, right? I hope. What's an index in a book? Yeah. It tells you where stuff is. If I'm looking for a particular subject in a book, right, one thing I could do is I could start at the first page and see if the thing that I want's on that page. And if it's not, I can go to the second page and I can see what's on that page. And then I can go to the third page and see if it's on that page. And just keep doing that over and over until I either find what I want or I go through the entire book, right? Or alternatively, it would be a little bit faster if I just flip to the very back in the index and I look up whatever it is that I'm looking for, and then it will tell me exactly where that thing is. And that way I don't have to cycle through every page. That is exactly what an index is in a database. It tracks where certain things are, so that instead of having to scan through every row in the table saying, is this what I want, is this what I want, is this what I want, it just goes to the index and says, the thing you want is right here. And then I can go directly to that spot. So if we're talking about performance, indexes are a great way to improve performance in a database. Alrighty, if I want to use SQL with my web pages, I have to have it interact with PHP. So how does that work? How does PHP interact with my database? What do I need in my web page to hook it up to a database? Yeah. The query function is the big one, right? The query function is what allows us to pass our SQL query to the database and get the results back. Before I can run the query function, I also have to tell it some information, such as where is my database, what's my login to the database, and all that stuff. We'll actually see an example of that a little bit later on when we start talking about today's studio. But the query function is very important for having your SQL databases interact with PHP code. MySQLi or PDO. Yes. Yeah. Yeah, exactly. A lot of that stuff's actually going to be done for you, at least for the studio today, and I think the problem set as well. But it is good to know those connection details. We'll take a look at an example of that, actually, a little bit later today. Okay, just a couple more. What's a transaction? Somebody explain a transaction to me? Didn't get that far, huh? Maybe? So a transaction, yeah. Okay, yeah, so if I have a database, it's probably not just one person looking for data, right? It's going to be lots of people, potentially. In fact, many people, perhaps even at the same time, could be looking for things. So we call that concurrency. I think somebody I think Rob gave a talk about concurrency a little while back. So how does a transaction help us with concurrency then? Or with multiple people interacting with the database? In fact, I'm not actually sure concurrency is the direction that transactions are going in. I think of transactions as a way of grouping SQL statements together. Let's say I've got 1,000 rows that I want to put into a database. But what happens if somewhere on row number 632 I have an error and it crashes? Now I've got X number of rows already in there, and another whole bunch of rows that I want to be in there, but they didn't make it because I ran into a problem. And so my database is now in this kind of half-completed state. It's in this kind of midway point, and the data might not be consistent without that second half. So we use transactions to group like statements together. What a transaction does is it says either all of these are going to go through or none of them are going to go through. So in the example that I just used, I would wrap those 1,000 row insert into a transaction, and if it failed on row number 632, it would actually go back and undo everything. Undo everything so that I was in the original state that I was in. It's a way of ensuring database consistency, ensuring that everything goes or nothing goes, and I'm not left in this kind of halfway limbo state in my database. Data integrity, data consistency is another very, very important concept when talking about databases. And transactions are a good tool to use to enforce that kind of stuff. All right, last but certainly not least, what is SQL injection? Yeah. Yeah, so if I have some text boxes, for example, on my website, and I take those values from the text box and I use them as part of a query against a database, some user could come in and write something evil, nefarious in one of those text boxes, and it would just get plugged in, and it could destroy my database, it could give them access to information that they're not supposed to have access to, et cetera, et cetera. That's called SQL injection. It's a pretty common type of attack against any website that might use a database. So how do we prevent this from happening? It's clearly a security issue. How do we stop it from happening? The short answer is we just, yeah. Yeah, so keeping things separate will definitely help, right? Separating out different pieces. We also can do a thing called sanitizing our inputs, which is basically looking for some things that are SQL-like. So take the text box, whatever the user typed in. If I look at that thing and I see stuff that clearly looks like SQL code in there, then I'm just going to say, hey, whoa, 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 buddy, right? I don't know what you're trying to pull here, but it's not going to work. So you can try to sanitize your inputs. You can try to remove SQL-like things. For example, the word drop is a very dangerous command in SQL. It basically blows things away, gets rid of stuff, entire tables worth of data. So you might want to have some kind of a filter for that on your text box. It's just looking for somebody typing the word drop in. It's a little bit more complicated than that, because what if the word drop is actually a valid response that somebody could type in? Well, then you have to allow it through in some cases. But in other cases, you definitely want to prevent it from hitting the database. So it's not necessarily an easy problem to solve, but it's been around for long enough and enough people know about it that there are some standard techniques for solving this problem. In this class, we are not going to try and hack your websites, I promise. Well, maybe I will just for fun, but okay, cool. Any questions about SQL stuff before we take a look at our next exercise? Actually, it's not an exercise, it's a demo. It's a demo. What I wanted to do next is actually take a look at one of the walkthroughs that we asked you to do in the prep work today. I realize that some of you might have already done this, which is fantastic. I am willing to bet that there are some of you that probably didn't do this, in which case this will be extremely beneficial. I don't just want to go through the walkthrough like David did, though. I want to ask you questions about it, make sure you understand the walkthrough, and maybe point out some additional things that weren't covered in the videos for this particular example. So I'm going to switch over to my IDE. And first thing I want to do, this is actually, if you remember, there was a walkthrough, an MVC walkthrough, that's based on the CS50 web page. This is not the actual CS50 web page, of course. Theirs looks a lot nicer than, oh, where'd my screen go? Come on. Come on back. Maybe. Thinking about it. All right. Let's try this. See if I can get it to go. There we go, cool. So here is a mock version of the CS50 web page. And if I click on the lectures link, it takes me to a page with lectures on it. And I can click on one of these, and it'll take me to a page with links to PDFs for the different lectures that were given during that particular week. And it works. It works just fine. It's a little bland. It's a little boring, but that's not really the point of this exercise. Let's take a look at the code for this. I actually have the code for this. And if I take a look, here it is right here. Let me zoom in on this so we can actually see. I've just got 4 files. One for the index page. You can see it's labeled index.php, but there's really not any PHP in here. It's just HTML. And another one for the lectures page. Right? And another one for week 0 and another one for week 1. Right? Now there's some problems with this that I think could use a little bit of massaging, a little bit of help here. Can anybody name a potential problem with the website as it's set up right now? Something we talked about a little bit earlier, yeah. So, yeah, so you mentioned the words header and footer. If I look at these pages, I see something that earlier I mentioned as being particularly undesirable from a programming standpoint. I've got this head section here with the title, right? And if I go to the other page, I see, oh, this one also has a very similar thing. And if I go to another page, I see, oh yeah, this one also has a very similar thing to it as well. So I see a lot of repetition. I see a lot of repeated stuff. And I don't like repetition. Repetition is a bad thing from a programming standpoint. To give you an illustration why that might be the case, consider, I know this page doesn't look particularly beautiful necessarily. It's kind of plain. There's not a whole lot going on. But consider if I wanted to change how this page looks, or if I wanted to change any of the information on these pages, what would I have to do? I would have to go to each file, one by one, find the thing that I want to change it. Which I know I only have 2 weeks on here, but CS50 is like a 15-week-long course at Harvard. That's a lot of stuff that I might have to change. That's a lot of stuff that I might have to change. It would take a long time, and it would make me kind of grumpy, to be perfectly honest with you. I would not enjoy doing that. I would not enjoy doing that. So what can we do to make this easier on ourselves? What's the technique? I'm sorry? CSS? Nope, not today. CSS would definitely make it look nicer. That much is true. But I'm not worried about how it actually looks necessarily today. Maybe another question. Is this an example of MVC right now? No? Why not? The answer is no. Otherwise, I wouldn't have asked you the question, right? But why not? Why isn't it an example of MVC? Yeah. There's no distinct separation between the model of the view and the controller. None whatsoever. So we can fix that. There's actually a computer science term for this. It's called abstraction. If I see repeated code that's repeated in multiple places, what I want to do is I want to abstract it out and turn it into a function and just use that function whenever I need to access that particular chunk of code. So that was actually the first step of this walkthrough, was to perform some of those abstractions. They did it with the header, so the very first part, and they did it with the footer as well. And so if we take a look, we can actually take a look at the result. If I go back and look at version 2 of this website right here, you can see it looks exactly the same. Well, that's actually a good thing. It's actually a good thing. In fact, there's a name for changing the code but getting the same result back out. What's that called? I'm sorry? Repeatability is a great concept, but not this concept. Yeah. What's it called if I have a program that works a certain way and I change the code without changing the functionality of the program? What's that called? Rhymes with, oh gosh, this is a tough one. Rhymes with, I can't even think of a word that rhymes with it. It's a concept I know we've talked about. It's called refactoring. Anybody who can think of a word that rhymes with refactoring without Googling it, you deserve a medal. I couldn't think of one. Anyhow, there is one problem though. I made the claim that it does exactly the same thing, that it works exactly the same way, but it doesn't. It actually doesn't. If you look at it, this right here, this CS50, is actually the same on each page. It was not like that on the original version. On the original version, this said week 1, right, or week 0. I don't remember which week. On the original version, this said lectures. Now it just says CS50 on every page. Why did that happen? Well, let's take a look at the code and figure out what's going on with this particular version. you see we did abstract some stuff out. In fact, if we look, I see, well, maybe the file will open for me. I've got these two files here, header and footer. I'd like to look at them. Here we go. The footer just has the ending piece of each page, and the header has the beginning piece of each page, right? And then how do I incorporate those in? I have this require function, okay? This require statement. What does this do? What does the require do? Yeah. Yeah, it's very much like the include statement in C. Yeah, that's a great analogy. It finds this file, and it literally takes the contents of this file and just copies them right in. Just pastes them right in there, right? That's what's happening. So for each of our pages, you now see at the top, I require the header, and then I require the footer. And that's why every page has the same title at the top, because I only have one header. I only have one header, and so I can only put one title in it, and so I chose CS50. But we lost some functionality there. It'd be nice if I could change this title depending on the page that I was on, like we had in the original version. So that's kind of what the next step tries to do. Maybe instead of just having one header and one footer, maybe I can generate the header and the footer when I need to, right? This is going to move us closer towards that model view controller, where I'm essentially going to be adding in some controller functionality, some controller logic. So let's take a look at what that looks like. If I look at the website, you know, again, it's going to seem like it's not that much different. You see, I got my titles back, so that's a good thing, right? So how do we do that in the code? Let's take a look. I have a new file, yet another file called helpers, and inside this helpers file, I have two functions, one that says render footer and one that says render header. So now instead of just having one header and one footer, I have functions that can generate specific headers and specific footers for me, right? So now I can actually customize these based on the individual pages. If I take a look at an example of how these are used, let's take a look at the index. I still require, well, I'm requiring a different file. I'm requiring helpers now, right? And now here you see that I call that function. What is this that I'm passing in? What is that called? It's an associative array, right? It's an associative array. The key is title, and the value is CS50. That's the title that I want this web page to have, right? So what does the render header function do with this information? Let's go back to our helpers file and take a look. If I look at render header, this is, what is this? That's my input argument to the function, but it's got this hanging on the back end of it. We haven't really seen that before. What is that? What is that doing? It's an empty array. Why is it there? What's it for? It's the default value. So if in my index page, right, if I don't give you anything, if I don't give you this associative array, it's just going to use an empty one by default, just so that it has something, right? So it has something to work off of. But we actually gave it some information. We actually gave it an associative array to use. So it's going to use that associative array. How's it going to use it? Well, you can see that it plugs it into this extract function. Now, this might be one of the more complicated pieces of this entire example. Can somebody explain to me what the extract function does with that array? Yeah, go ahead. It puts it in scope, yes. That is the official PHP documentation definition of the extract function. Yes, absolutely. It's not wrong. That's exactly right. Well, can somebody explain that to me in English? Yeah. Yeah, exactly. So it's going to look at each key in that associative array. In this case, we have one. It's called title. And so what's it going to do? It's going to make a variable called title. And in that variable, it's going to store the value. So if I go back, it's going to create a variable called title, and that variable is going to have a value of CS50. How does that help us? How does that actually help us in this particular case? Well, if I go back, you can see that the next thing that it does is that it requires header.php. So if I go look at that file, you can see that it's using a variable called title. Where did that variable get created? It got created when we used that extract function, right? So it's kind of a multiple step process to get here, but it's pulling that associative array, turning it into a variable, and then using that variable in the header to dynamically display the title. That's what allows us to have a different title on each page instead of just a single title on every page. Does that make sense? It's a tricky, kind of a tricky part to grasp. But it's good from a programming standpoint. Now if I want to change the title of something, what do? Well, I have a function that handles all of it for me. All I have to do is just set a new title, and boom, done, right? Okay, yes? Well, yeah, so we will, the question was, what if we don't pass in a title or anything? It is going to use an empty array, so it's not going to extract anything. And then we may get an error when we try to render the header because there's no title in that case. It would be better to actually try it out and run it and see what happens, which we could certainly do if I just come in, oops, I didn't need to do that. If I just come into one of these pages and I just take this out, save it. This was the index for number 2, so we could go back and take a look. If I try to refresh, the title just disappeared because it didn't have one. The variable doesn't exist because we never set it. Yeah, great question. Any other questions? Before I move on. So there's still a problem with this. There's still a problem with this, and to explain the problem, let me go back to the header and the footer. If I look at what the header and the footer look like now, well, the footer is still basically the same, right? The header is also similar to what it was in the past, but now it's using this variable. But we really could try to condense this even farther. We really could try to condense this even farther and have one function that's capable of generating a header or a footer, depending on what we need, right? That would be an even more dynamic approach to solve this problem. So I believe that's what happens next. I hope I didn't skip a step. Let's see. Yeah, that's exactly what happens next. So now what we're doing is we're taking this one step farther. Instead of having 2 functions, one for the header and one for the footer, I've got one function that can handle both. How does it do that? Well, you see I've now got this extra input argument called template. And that's what's going to tell me whether I want to use the header or the footer. That's what's going to tell me which one I want to use. So what does it do? It constructs the path, stores it in a variable, and then it tries to use that path, right? It tries to use that path. So if I go back to my index page and I look here, you see the advantage of doing it this way is that I now have one function that I'm using multiple times instead of 2 functions in each of these files. So, and the code that I have, the code that I've written in this helpers file is significantly less than it was before. That's less code I have to manage, that's less stuff I have to modify if I want to make changes to my website. Right? That's the real advantage of this MVC approach. So I'm actually going to skip maybe number 4 and go to number 5, the final results, which really just includes maybe some organization for our website. The functionality is essentially the same. If you look at the helpers file, it looks very much the same. The biggest difference here is that I've organized everything into folders. So I've got all my includes. This is really my controller stuff, right? This is my controller stuff. Includes, think controller. This is my logic. What is the stuff that I need my web page? What is the stuff that my web page needs to render itself? Inside of public here, you see this is content, right? This is the actual stuff that I want to be displayed on my web page. So we can think of that as the actual content. And then templates here describe formatting or the view. How is stuff actually going to be displayed? How is it going to look? And so by the time we get to this finished version of this walkthrough, we have a nice MVC version of our website. And again, if I go and I look at version number 5, the very last version, one of the nice things about it is that it looks very much the same as the first version, right? It looks very much the same as the first version. It's just a lot easier for me to maintain. A lot easier for me to make changes, a lot easier for me to change stuff, update stuff, and maintain my code. Are there any questions? Any questions about this walkthrough? I think it was a really important walkthrough. I want to make sure to go through it because you're going to see it again in Studio today. You're also going to see it again in the problem set this week. So I really want to make sure to go through this example. Yes? Yeah, so I didn't really talk about which one was the model. Which part's the model again? What am I looking for with the model? We've been considering that equivalent to a database. We don't have a database at all in this one. Do we still have a model though? Do we still have a model? What do you think? It's possible to have a model without having a database. It doesn't have to be a database necessarily. There's other ways to represent our data. What is our actual data? In this particular case, it's just the the links to stuff, right? So if you wanted to make a case for a model, you might consider stuff like this potentially to be the model. I don't know. Personally, I think that's kind of a weak argument myself. But in terms of the other components, the view and the controller, for view stuff, I'm really looking at where's the HTML, where's the CSS. We don't have any CSS, but we do have some HTML. So this is kind of part of the view here. We also have some of these templates down here which define parts of the view as well. And then for the controller, that's any logic that's going to happen. That's going to be our PHP primarily. So in the helpers, we see this is our one PHP function. And I also have some PHP integrated in with the web page itself to call this function. That's all part of the controller piece. Are there any additional improvements that we can make to this? Is there anything else that we could do to make this even more dynamic for the design? Let me go back to the original. It might help to see. So we've got, lectures, syllabus. I think there's some work that could be done here with the lectures, actually. I think there's some work that could be done there. Consider, I only have 2 weeks here, week 0 and week 1. But by the end of the semester, I'm going to have a lot. 15 or 16 or however many weeks there are, right? And as of right now, each one of these is just hard-coded in there. Well, I could dynamically have it detect, how many weeks I have and load each of those up. I could use a loop or some other structure to just say, start with week 0 and iterate through all the different weeks and render each one, right, that way. And that would be an even more dynamic design than what we have now. I'm not going to do that, but if you wanted to continue, that could be a further improvement that you could make on this particular design. Any questions? All right. I haven't talked at all about databases yet. I do want to talk about databases at least a little bit. But before we do, I want to actually kind of take a quick break and do something a little bit different for the next 15, 20 minutes or so. Since we are getting closer to the end of class, one thing that's going to become important, especially if you're planning on applying for the apprenticeship process, is you're going to be talking about code a lot. You're going to be creating a project, and someday you're going to have to explain that project to somebody. You're going to have to tell them how it works and what you did, how you made it, right? And be able to explain your code to another human being. It's a very important skill to develop, and not one that we've actually spent a lot of time talking about up until this point. So what I would like to do for the next 15 or 20 minutes is ask you to pair up with somebody, find a buddy, find a friend, pair up with them, and go back to one of your previous problem sets or a studio or an exercise you worked on, or it can be literally anything that you've written, and I want you to explain your approach, explain how you decided to do what you did, and walk through your code and explain it to that person. Now, they might already understand it. They might already, have a feel for how the code works because they probably completed the problem set as well. But it's still good to get used to explaining your code to another human being. That's the skill that I really want to practice right now. To help you out with this, I've created some guidelines for you to think about as you go through this little exercise. So for the explainer, some things that you might want to include in your explanation, right? How did you decide on the design? How did you end up on the design that you came up with? What were some of the more hard, difficult pieces? Point out some of the hard parts, explain why they were difficult and how you actually managed to figure them out. And then is there anything that you're currently unhappy with? Anything that you think could stand to be improved even farther? And then for the person that's listening, some things to think about, some things that you might want to ask the other person. Of course, do you understand the design? Is it efficient? Is there anything that could be improved in terms of the design? Are there any other problem areas that you see that could be addressed that maybe the other person didn't think of? They didn't notice because they were working on it? And this is another interesting question. Would you be able to understand the code without the explanation? There's something to be said for clear, easy to read, understandable code. Not all code is going to be like that, of course. But in general, we want our code to be as self-explanatory as possible. We want to be able to hand our code to somebody else and have them look at it and be able to understand it on their own. It won't always happen. That's why we're practicing explaining your code to somebody as well. But these are just some ideas, and I'm hoping you'll come up with some other ideas and questions as you go through. So to give you kind of a push here, some things that might be good to talk about, some code examples. I think if you've completed PSET 5, I know not all of you did Module 5, but if you did complete PSET 5 and you find somebody else that's done PSET 5, that would be a great one to explain to somebody else. If you didn't do PSET 5, I think PSET 3 would also be a great one to walk somebody through. You're not limited to those. If you have a studio or an exercise or something else that you'd rather explain to somebody, that would work perfectly well too. But I'm gonna stop talking now, and in a few minutes, I'm gonna ask you to switch. So one person's gonna explain for the next 5 to 10. I'll make an announcement, and then you'll switch, and the other person will have to explain a piece of code to you. Any questions? Any questions about what we're doing? All right, go for it. Find a neighbor, find a buddy, and start explaining some code to them. Okay, if you haven't done so already, switch. Whoever was explaining is now the listener, and whoever was listening is now the explainer. Alrighty. I hate to stop you because I see some great conversations happening, but we are about out of time. So how was that? Was that useful? How many people learned something just now? No. Yeah, great. I find that I actually learn things by explaining what I've done to other people, even though I've already done it. Even though I've already done it before, I find that by explaining to somebody else, I actually learn more about it, perhaps, than even when I did it the first time around. It can be a very educational process. How many people actually fixed some problems or some bugs in their code just now based on what they talked about? That's excellent. I love that. That is fantastic. Even if you didn't, that's fine. I mean, that wasn't the stated goal of this exercise, but I'm glad that that happens anyway, even though that wasn't something I directly asked you to do. Talking about your code, explaining to somebody else is a good skill, and it's also extremely useful just from a coding perspective. Fantastic. I think that went really well. We might try and do that more often. Okay. We don't have a whole lot of time left, but we do have a little bit of time left, and I would like to use the remaining few minutes to kind of go over the studio for today. There is a bit of setup involved, and so we have about 10 minutes, and I would like to try and maybe get through as much of the setup as I can in that 10 minutes. So if you are planning to work on the studio and you want to kind of follow along with me as we go through the setup, so that we're all kind of on the same page. And that way, when we're done, you can just hop right in and start working instead of having to get through the setup for this particular studio. So let's go ahead and get started. I'm not going to explain what the goal of the studio is necessarily. Well, yeah, I can give you a quick version, actually. It's pretty simple. We're going to be greeting people. We're going to be greeting users to our website. So you can see there's a little form here where you type in your name, and then you can select a greeting that's already been created, or you can actually create additional greetings for yourself. And then when you click submit, it just says, what's up? What is up? That's, very formal. And then it also tells you how many times that greeting's been used, right? So this is something that we haven't been able to do before. Well, we kind of have been, right? How do we solve this problem last time with counting the number of times something has happened? Sessions. So last time we talked about sessions, and we could use sessions to maybe do something like this. But there's something that sessions can't do for us, which is, let's say somebody else visits your website. They don't have access to my session. So this, when it says this is the 4th time I have said what's up to someone, that's not just the 4th time they said what's up to you, that's the 4th time they said what's up to anybody who's come to the website, right? It's global. Sessions are very much one user. It's like a direct link between the user and the website. So you can use it to record stuff. What we're going to do with this website is something that's global to all the users of the website. In order to make that work, we need a database. We need to actually store this stuff. We need persistence, is what we'd say. So that's what the studio is going to be focused on. So it goes through some more directions about how the website works and some of the functionality. You should definitely read this. Do as I say, not as I do, as I scroll down past that stuff. I really, with the remaining time, would like to try and get through some of the setup stuff, just so that we're all on the same page and try to, tackle any problems as they come about. So the first thing you have to do is grab the starter code for this, which there's a wget here that you can use for that purpose, which I'm going to go ahead and do right now, and grab the code. I should mention that this is actually a very similar set of starter code as what you're going to see on PSET 7. This studio is modeled very much around the same structure that PSET 7 uses. This is good practice for that PSET. And then once we have this file, it's not very big, it shouldn't take too long. We can just say unzip there it goes, greetings.zip. And you can see it extracts everything. So far, nothing super new. We've done this kind of thing before. After that, it gets to be a little bit more involved. The next thing that I want to talk to you about with the last 5 minutes, again, you see I'm skipping all this explanation. Please, 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 please read this stuff. Please go through this stuff. I do not have time to do so. I really wish that I did, but I don't have time to do so. I want to actually talk to you about setting up the database, because this is something that we have not done before. So I think it would be nice to try and get this done before we end the session today. So the first thing you can see that we need to do is we need to start Apache. So I'm going to go into my public folder and start Apache in that folder. So I'm going to go into public, greetings/public. Here I am, and I'm going to start Apache. Oh, it's already running. Okay, fair enough. Apache 50 stop, and then Apache 50 start. And then the next thing that needs to happen, if we go back to the instructions, is we're going to start our database. We're going to start our database server. The command for that is MySQL50 start. I'm going to go back to the IDE and type in MySQL50 start. This is going to start up a database for us. This is going to create a database that we can use to help us with this studio. So it's going to go through some steps to set up MySQL. And while it's doing that, we can kind of take a peek at the next step, see what we're going to have to do once this is finished. The next thing that we need to do is actually log on to the database and create a table for us to use for this studio. So we're going to go to our web page, which mine you can see is already kind of here. So go to your web page. And right now I got an error. That's actually expected. This is something that you will eventually fix. You will eventually fix this problem. Let's see if it's done doing this stuff. Yeah. Yep, so it's done doing that. So what I'm going to do is I'm going to put a slash on the end. And I'm going to say, what is it, PHP my admin. PHP my admin. And that should take me to the administration page for my database. How many people have already done this through the prep work and got set up this far? Good, excellent. I see a lot of people who haven't, so hopefully you're following along with me. The next thing we have to do is we have to log in with the username and password. To get that information, again, I'm going to go back to the IDE and do a couple more commands. One is username 50. That'll tell me the username. Oh, hey, look, it's just my name. Go figure. And then password 50 gives me this gibberish-looking password. And I can just go ahead and copy-paste those in to the login form here. Okay. I'm just going to go ahead and paste those in. And then I go ahead and log in. I don't like saving passwords. I'm not going to do that. And now I'm actually logged into PHP my admin. And now if we want to, we can create a table, or we can actually run queries from here if we want to as well. But for our purposes, excuse me, what we really need to do is create a database and create a table for us to use for this particular studio. This is probably about as far as we're going to get, since we are about out of time. So in order to do this, what we're going to do is at the top, there's a tab that says SQL. I'm going to click that. And it gives me this blank box. And I can type a SQL query in here. So any of the SQL commands that you read up about on the prep work, I can type those in here and they'll work. There's a few commands that we haven't talked a whole lot about, but I'll mention them briefly right now. If I look at this code right here, I'm actually just going to copy all of it and paste it into that box. But before I run it, I kind of want to explain what's going on a little bit first. I'm going to copy all that and paste it into this box. And let's just real quickly go over this code and take a look at what it's doing. The first thing it's going to do is create a database for us. And the name of that database is going to be called Module 7 Studio. That's the name of the database. So a database is what contains the tables. Okay? The next thing we're going to do is actually create a table. We're going to create a table called Greetings. What is this stuff down here? What are these lines here? ID, text, num times. What are those? Anybody have an idea? Yeah. Columns. They're going to be columns, right? So we're creating a table called Greetings. This is the first column in my table. Text is the second column, and num times is the third column of my table. Afterwards, we're defining the data type. So ID is an integer, right? Text is a varchar, and num times is another integer. Right? We define what the primary key is, ID. And then we also say that the text column has to be unique. That means it can't contain any duplicates. Cannot contain any duplicates. That's actually an important part of the studio. That's something that you'll have to keep in mind as you're working on this studio. And then finally, down here at the bottom, you can see that I insert some values. Insert into greetings. I have 3 lines. I insert 3 greetings, hello, cheers, and what is up, into my table. What about the other columns? What about ID and num times? Where are those in the insert statement? Why don't I have those in here? What's going to happen to those? Anybody see what's going to happen with those? Yeah. So ID, there's actually 2 things going on here. ID is a little bit different. It's set to be auto-incrementing. So ID is going to be generated for us. Our primary key is just going to count up 1, 2, 3, 4, 5, 6, 7, right? Just going to keep counting up for every row that we insert. What about num times? What's going to happen with that? Yeah, I haven't specified what that value is, so it's just going to default it to 0 probably. Let's actually try it out and make sure that that's what happens. If I click go, it should run it for me. So it looks like it worked. It looks like it worked. Now, if I want to actually see what's inside the table now, I can actually come back here. Can somebody give me a query that says just return everything from the greetings table? What would that look like? How do I query the greetings table? How do I get everything out of it? Yeah. Select star from greetings. I think it's all lowercase, right? So the select clause, I have star. Star stands for everything. Give me everything. If I didn't want everything, what could I put here instead? What might you also see in the select part? Not just star, but I could also see what? Column names. I can also see column names. So if there's only specific columns that I want, I can use select to specify which columns from a table that I want. The from clause is used to specify what table I'm going to pull stuff from. So select is columns, from is tables. There's also a way to filter out rows. We don't see that here. I have a feeling Mike might talk about that a little bit in his advanced SQL talk in just a bit. But this is enough for us to see what's inside of that table. So let's run this query and see if, oh, no database selected. All right, I made a mistake. No database selected. I can fix that, though. How do I fix that? I need a use statement. Use module 7 studio. That's the name of the database that we created. So now if I try this again, hopefully it'll work. All right, cool. There are the rows that I inserted, right? Hello, cheers, and what is up. And for num times, you see that it did use just a default of 0 in each of those. That's as far as I'm going to have time to get to right now. So Mike is going to be starting his advanced SQL talk in just a little bit. You can also keep working on the studio. Eventually, you'll have to set it up so that it can insert new greetings into this table and also count how many times each greeting has been used. So you're going to get some practice doing SQL. I wish I had more time to cover some SQL topics. Unfortunately, we are out of time. But we've got lots of people around to help you out if you get stuck, if you need some help. At least you're set up now, right? So I think that's going to do it for me. If you are interested in the advanced talk, I think Mike will be ready to go in 5-ish minutes or so in this side of the room. So you can make your way in that direction. Otherwise, let us know if you have any questions about the studio. Thanks.